In today's lesson, we're going to be talking about word problems that are exponential. So we actually have three different types of word problems we're going to talk about. The first one is going to be considered exponential growth. So an exponential growth is where something is growing at a rapid rate over time. Now, you can use f of x or you can use the letter y. I don't care if you use a function notation or an equation notation. But here's the main part. It says a parentheses 1 plus r, close your parentheses, raised to the x. A is your initial or starting amount. R is your growth factor percent, but the catch is you have to change a percent into a decimal. All right, now in case you don't remember that, to change a percent into the decimal, you have to move the decimal point, which I'm abbreviating all that, move the decimal point 2 places to the left, which you'll get to see that in action when we get down to our examples. And then the last variable we have is x, and x stands for time. And most of the time it'll be in years. Sometimes it could be in months, but most of the time it's going to be in years. So if we look at example number 1, okay, when I'm reading example number 1, in order to be a growth, I need to see a word that says something about things are getting larger. So if I scan, does everybody see where it says increases? Increases lets me know that this is going to be a growth. So I know it's this formula. So I've got y equals A. A is the starting amount. So how much money did we start with? Well, we started with 1,400. Parentheses 1 plus R. Well, R is 9%, but what is 9% as a decimal? So remember, the decimal is after the 9, so you have to move it 2 places to the left. So is everyone okay with R being 0.09 raised to the x? Then I'm going to go ahead and clean this up. So what's 1 plus 0.09? So that would be y equals 1,400 parentheses 1.09, close my parentheses, raised to the power of x. So that's my equation. Now I'm going to use this equation to help me find how much money I would have after 25 years. So now we're going to plug in 25 for x, because remember, x is time. Definitely want your calculator for this one. So you're going to type in 1,400 parentheses 1.09. Make sure you hit your exponent key, the little roof of the house key, and then type in 25. And since we're talking about money, we're going to round it out with change. So I came up with $12,072.31. Okay, next one. When I look at this problem, I see the word increasing again, so that means growth. So y equals starting amount, $149,999. Parentheses 1 plus, move my decimal over twice, 1, 2. So 0.045 raised to the x. So I'm going to clean that up a little bit. So that would be 1.045 raised to the x. So there's my equation. Now I'm going to use my equation to figure out how much money it would be after 7 years. So now plug in 7 for x on your calculator. Remember to hit your exponent key and then 7. And when I did that, I came up with $204,127.91. Okay, my second type, instead of being an exponential growth, is now an exponential decay. And you're going to notice what's the only difference between the formula up above and this formula. And that is going to be that instead of it's 1 plus, it's now going to be 1 minus. Okay, so A is still the starting amount. Your rate still needs to be written as a decimal, and X still stands for time. So on problem number 3, look for a keyword that says you're going down, you're losing money, you're getting rid of stuff. And does everybody see the word depreciates? Depreciate means it's losing value. So that's a decay. So Y equals starting amount, 50,000, parentheses 1 minus, because it's a decay, 10%. So move the decimal 2 places. So you get 0.10 raised to the x. So I'm going to clean that up. 50,000. And 1 minus 0.10 is 0.9. Or 0.90, however you want to write it, raised to the x. Now use this equation to figure out the value after 7 years. So plug in 7 for x on your calculator. Make sure you hit the exponent key again. And I got the value to be $23,914.85. So number 4, looking for a keyword. Oh, I see a keyword of decreasing. Okay, so that means it's a decay. So Y equals starting amount, 88,647. 1 minus, move my, even though my percent is a decimal, it still has a percent sign after it. So it's a percent. So change it to a decimal by moving it 2 places, 1, 2. So you would have 0.003 raised to the x. And if I clean that up, I get 88,647 parentheses 0.997 raised to the x. Okay, now when you're looking at this one and you're going to say, what am I going to plug in for x? It doesn't say after 8 years, after 10 years, after 20 years. It just says, what would the population be in 2010? So I need to figure out how much time has went by. So what was my starting year? So my starting year was 2000. And my ending year that I'm asking for is 2010. So how many years have gone by? So what is 2010 minus 2000? And hopefully everybody says, oh, 10 years has went by. So I am going to plug 10 in for x. So use your calculator. Make sure you hit your exponent key and put 10 in. Now, this is people. So we can't have a half a person, a fourth a person. We can't have any decimals. So no decimal point on this one. We're going to just round down to people. So I would say it's going to be 86,023. You can't round up. Even if it says 23.9, you can't round it up to 24 people. Okay, you have to always round it down. All right, last formula. And this one is for compounded interest. And this formula looks a little bit massive compared to the other ones. So let's go through and break this one down. A is the amount paid. So that's usually what you're always looking for. Equals P. P is called the principal amount, or that's still better known as the starting amount. Just a fancier word. R is the rate. Once again, just like all the others, you have to make sure you put your rate as a decimal, not a percent. N is the number of times per year the interest is compounded. So that's a new one. We're going to talk about that in just a minute. And then T still stands for time. All right, so we've got some different cases that can happen here. So let's say, oh, my dogs are barking. Not sure if somebody's at my door. Hold that. All right, sorry about my dogs there. So on this one, let's talk about N. N is the number of times per year. So this is what we could say. What if they said it was compounded quarterly? So if it says quarterly, well, I think how many quarters are in a dollar? And hopefully everybody says, oh, 4. So compounded quarterly means 4 times. So you would say N is 4. Now it could say compounded monthly. Well, how many months are in a year? Hopefully everybody says 12 months in a year. So N would be 12. Okay. It could just say annually. Annually. Annual just means 1 time. So that just means N is 1. Could say daily. How many days are in a year? 365. We're just going to kind of round it there. We're not going to worry about the technicality. Okay. Or the last one it could say is semi-annually. And semi-annually means that it's done twice a year. All right, so let's go down and look at our problem. So on example number 5, do you notice that it does say the word compounded? If you see compounded, that throws it into this category. So we have A equals starting amount. So look at the certificate off to the side, and it says the starting amount is $3,000. Parentheses, 1 plus R. What's my percent? Well, my percent is 8%, so move the decimal over twice, and I get 0.08 over N. Well, it says it's compounded quarterly, and quarterly up above we said means 4. Close my parentheses. And then we have N, which N we just said was 4, times T, which is time. And how many years are we doing this for? 5 years. Now, if we're going to use our calculator, we do have to type it in. Okay, so follow along. Type in 3,000, open a parentheses, 1 plus. Now, here's the important part. We have to put another set of parentheses around my fraction. You cannot use the fraction key because you have a decimal. And if you try to use the fraction key with the decimal, your calculator will say, error, can't do it, can't do it. So since we have to physically hit the division key, I need to put that part in parentheses so that the calculator knows which part I'm dividing. So yes, right here, I do need a green parentheses, a blue parentheses. So I do need a double parentheses right here. Then we're going to hit our exponent key. And since I have more than one item in the exponent, I also have to have a parentheses here. So I have to do parentheses 4 times 5. Close my parentheses. And when you type all of that in, I came up with, this is money, so round out to change, $4,457.84. Okay, next one. So this one, it says, will the value of the CD be greater 5 years after it's compounded annually rather than quarterly? Well, we already know the answer for quarterly, but now we have to find the answer for annually. So once again, A equals starting amount, 3,000. 1 plus the interest rate is still 8%, and 8% is 0.08. But this time we're not going to have 4 on the bottom. If we're going to do it annually, this time we're going to put 1 on the bottom. Close my parentheses, raised to the 1 times 5. So remember, when I type that in my calculator, 3,000 parentheses 1 plus open in parentheses 0.08 divided by 1, close, close, exponent key, open, 1 times 5, close. And I got $4,407.98. So is that greater than our above value? And I would say, nope. This is actually smaller than the answer up above. Okay. Last one. What will be the difference after 5 years if it is compounded monthly instead of quarterly? Well, once again, we already know the answer for quarterly, so now let's do monthly. So A equals 3,000, parentheses 1 plus 0.08 over monthly. Monthly now means my N is 12 raised to the 12 times 5. So once again, calculator, 3,000, parentheses 1 plus parentheses 0.08 divided by 12, close, close, exponent key, open, 12 times 5, close. And I came up with $4,469.54. Now, if I want the difference means subtract, so I'm going to take that and I'm going to subtract away my quarterly. And my quarterly was the answer for A. So my answer for A was $4,457.84. So if I subtract them, I come up with the difference to be $11.70. Done. So as always, you have to do the try it ones here to get full credit. So we'll talk about them in class. Thanks.